Nice to see you all. Hello. Greetings from Warsaw, and Muhammad, in your case, greetings from Pakistan. Where is, how much you said, 9 p.m.? Yes, right now?
Yes, yeah,
So we welcome all of you to our seminar, where Muhammad today is the speaker. So Muhammad, floor is yours. Good luck, and yeah, all the
thank you,
best.
Katya. Hi, hi everyone. Thank you. I hope you all are doing well. So I am going to present a chapter on first chapter on my thesis. So I'm basically working on regional health inequalities and child health outcomes. So I'm going to be talking about how uh, conflicts, climate change, along with socioeconomic deprivation, influences child health outcomes. So let me quickly go through the outline. So this is sort of an outline that I'm also following uh, in my write-up for the first chapter, just a bit brief when it comes to existing literature. So I'm going to briefly discuss about uh, child malnutrition, how to define what sort of different types of child malnutrition there are, then the worldwide landscape of child malnutrition, comparing different regions and regional, let's say, global inequalities, then different theories on child malnutrition, and this will be followed by existing research. What are my contributions, novelty and research gaps, and then a broader research statement. I will briefly go through research methodology because I think this is like really important to discuss how I extracted and aggregated data from satellite images or raster files to municipalities. Then I will briefly talk about statistical methods, and then I will present some interesting findings and also the challenges that I face and I still like I'm facing when it comes to model estimation and the potential solutions that I have in my mind. Okay, so well, for the developed world, I believe child malnutrition is not well known because I had the chance to present in a couple of European countries and where I thought, well, everyone knows, but then I realized, well, not everyone around the world knows about child malnutrition because this is a problem which is more apparent or prevailing in developing and low and middle income countries. It's a critical global issue because it affects millions of children worldwide. It does not only undermine their health and growth, but also the growth of nations. So, and it includes different spectrum of nutritional imbalances, and it is further categorized into stunting, wasting, and underweight. And now, in recent times, researchers and different organizations they have also started to include overnutrition, which is a growing problem around the world. And to put it in simple and brief words, uh, they have proposed that it's a multifaceted, multidimensional phenomenon that mainly results from nutritional related deficiencies, but there are different indirect and potential, direct and indirect potential pathways that affects these, let's say, food security related measures, then that in turn affects our children intake, which affects child health outcomes. So, as I already said, we have different types of child malnutrition measures. So the first one is childhood stunting. And just to make it clear, when I say childhood stunting or child malnutrition or childhood wasting, we are talking about children who are under the age of 5 years. So stunting is defined as if the height of a child doesn't correspond to the age. Then we say that the child is suffering from stunting or he has a stunting growth. Wasting, on the other hand, if the weight doesn't correspond to the height, so there are predetermined or pre or declared uh, height levels or let's say age or weight levels for the children which are described or declared by WHO or UNICEF. And then we have underweight, which is a combination of stunting and wasting. So the child whose weight doesn't correspond to his or her age. And just to make it more clear, I think it's easy to understand when if you have some visuals in front of you. So on the left hand side, we have a child which seems to be or which is normal. And on the right hand side, we have children who are supposed to be suffering from wasting. So as I already mentioned, if the weight doesn't correspond to height, then the child is suffering from wasting, and the stunting we have low height for age, and then we have underweight, low weight for age. And then if you compare that to normal child, we can easily see the differences. So children, if he is suffering from either of these three measures, they are considered as child malnourished children. And for this study, I'm only considering childhood stunting, and I'm going to explain why I'm focusing only this measure. This is the global landscape of child malnutrition, and we can see that let's say, the most vulnerable or the most dangerous or alarming such a situation is stunting, because we have around 155 million children in the world who suffered stunting in 2019. And along with that, we had 41 million children who suffered from overweight, and then 52 million from wasting. But when it comes to these regional, let's say, comparisons or variations, we can easily identify and see that in Africa and Asia are the two regions which have the highest number of stunted and overweight, and then let's say wasted children in 2019. So if we say, okay, in the coming years we would be, or the world would be free from malnutrition, well, it's impossible, it seems, because we also need to take into account that we had, after 2019, we had COVID-19, and I'm still, and a lot of people are still waiting for the, let's say, latest updates on child malnutrition, because I certainly believe, like others, because COVID must have affected the intervention programs or must have affected child health outcomes. So let's see what happens when the new they publish latest estimates on child malnutrition. And out of these 155 million children, 112 million children, they reside or live in conflict exposed and climate vulnerable regions, and which translates to 67% of all malnourished children, and which is quite a huge number if we compare that to the overall child malnutrition rates. And to see how, like to see the developments over time, and whether these developing countries or the world has seen any improvement, or there are definitely some improvements. But when it comes to stunting has the slowest improvement from 2000 till 2016. So even in 2016, we had around 154 million children having or had stunted growth, and even per 2019 estimates, it's still around the same. There were improvements when it comes to wasted children, but there is also another quite surprising and I would say alarming situation, because this overweight number is increasing. So maybe in the future we would see a lot of other studies focusing on obesity or overweight issues along with stunting. So this is one of the, as I said, I'm focusing only on childhood stunting. So these are a couple of reasons why I have considered childhood stunting for my research, because majority of the children, they are suffering from stunted growth, and the improvements, when it comes to improvements or the developments over time, well, it's the slowest among other child malnourished measurements. So let's dig more deeper into regional variations. So even when it comes to regions, let's say Africa or Asia, we can further see that within Africa or within Asia, like we have Southern Asia countries like Pakistan, India, or Afghanistan, Nepal, Sri Lanka, they had 34.1 million children who had stunted growth. And then if we talk about Africa, there's also a huge amount of variation when we compare Western African countries to Northern Africa or Middle Africa. So even within, let's say, continents or regions, there exists a lot of heterogeneity, or there exist huge variations. So we shouldn't ignore that. And to give you more facts on Southern Asia, so in South Asian countries, 2 out of every 5 children they have or they were faced with stunted growth, and that's like a lot when it comes to comparing with North African or African or other regions. And to give you a more surprising fact, well, those numbers were more at the country level or regional level, and this picture shows estimates or data at the raster level. So this is at the 5 kilometer resolution. And when I was looking through the estimates or data for the countries, so they would say, okay, the countries in South Asia, they have 30% or 40% stunted growth. But when you look at these raster files or raster images, even within a country, let's say Pakistan, or they fall here, like, or India, there are regions, or let's say places where we have more than 80% or around 80% of stunting. So this is huge. So if you compare that with national figures or national estimates, that's quite alarming. So this is why one of the reasons that I'm trying to conduct my analysis at the most possible, let's say, micro level to capture this heterogeneity as well. So next, well, there are a lot of theories that have been proposed by researchers in the past to study this phenomenon. And our time and they have agreed to move from monodimensional to multidimensional, let's say, factors. And in 1990s, WHO and other organizations, they realized that this phenomenon cannot be treated as monodimensional. So that's why they proposed this theoretical framework, which somehow tries to underpin the direct and indirect potential pathways that affects child health outcomes and thus consequently child undernutrition. Um, I'm also using this theoretical framework in my research. So basically, they have classified this framework into 3 different causes or factors. So first we have basic causes, then we have underlying causes, and then we have immediate causes. So basic causes is it's more like let's say broader phenomena where we are considering socio, political, cultural context. And remember, it's not easy or possible to have data for all such measures. So we try our best to retrieve or get the proxy for such measures, and then we try to relate it with underlying causes, because basic causes somehow affects underlying causes, and then underlying causes, they affect immediate causes, and then those immediate causes affects child health outcomes. So the next is underlying causes. So underlying causes are more considered, or they include the household and community level factors. So let's say household food security, if they have access to sufficient, safe, and nutritious food. It also considers child care or health practices. Then if the children, they have access to immunization or the healthcare services, if they have access to clean water, sanitation, and hygienic facilities. And remember, all these underlying causes, they somehow affected by basic causes, because basic causes also considers governance, institutions, policies. because these policies, they also affect these underlying causes. And then we have the immediate causes, which directly affects the child health outcomes. So in immediate causes, we can have, let's say, if there were floods, which I'm considering as the basic cause, which affects the underlying cause at the crop yield, which is considered as or proxied as food security. So if it affects underlying cause, then it means the households are not or they don't have uh, let's say good nutritious food available at their disposal. So this is the immediate cause that affects the child health outcomes. Then you can also relate, let's say, immediate cause diseases. So we have, let's consider this to another, let's say, channel. Let's say we have a basic cause of climate change. There are excessive rains because we know climate change also affects food security, but there are there have been some quite a lot of research which has proven that excessive rains or droughts, they also uh, led to vector-borne infectious diseases, so which also exacerbates or affects child health outcomes. And if there are droughts, let's say it also affects underlying causes because they are not, we don't have, or the household, they don't have good sanitation and hygienic facilities, which can lead to diseases, which in turn affects child health outcome. So this is not an, let's say, an easy phenomena to model, as you can see here from this theoretical framework, because all these causes somehow interlink with each other, and then there are either direct pathways or indirect pathways through which it affects child health outcomes. So I think I'm not gonna waste more time on this one. So what about the existing literature? So along with units of theoretical framework, there are other theories like socioeconomic theory or ecological theory, and recently social determinants theory. They also try to pinpoint the multidimensional, let's say, factors which are responsible for child malnutrition. And we know, like, when you search or do some research on this child malnutrition, you would find abundance, like studies using socioeconomic factors only as the main determinants of child malnutrition. Like majority of these studies you would find easy, like they are just considering some socioeconomic features such as, I already mentioned a few, like availability of electricity or some other household factors, or availability of safe water and sanitation facilities as the leading causes of child malnutrition. But lately there have been few developments, and now I think maybe because of the availability of data, or maybe I don't know, some other reasons, and also because back in 1990s and recently there have been other multidimensional frameworks. So we have started to consider how climate change, such as droughts or other extreme conditions, affects child health outcomes. So I mentioned when I was explaining this theoretical framework. So if we have extreme conditions, extreme climatic conditions, there is a possibility, or it's a proven fact, that it affects crop yields, which in turn is proxied as food security, so which affects also child health outcomes. So there are two possible channels, but there's also another one interesting channel, which I think I will also try to maybe model in my other chapters, because climate change, let's say excessive rainfalls, they also somehow affects provision of health services, I think, which have not been modeled as well. So there's also another way we can explain how climate change affects child health outcomes. And as I am trying to focus more on conflict affected and climate extreme regions and how they relate with child health outcomes, and I searched quite a bit to see what's going on and how people are relating conflicts along with climate change to child health outcomes. And lately, I think I found only one study in which researchers have tried to consider the impacts of both conflicts and climate change and how it affects child health. And just to mention here how conflicts basically affect child health outcomes. So conflicts also disrupt food supplies, they also disrupt provision of health services, and they also can potentially create a sense of fear among, let's say, common people, and thereby it can also affect health-seeking behavior. So there could be multiple pathways to which we can explain how conflicts affect child health outcomes. But there is not much. I mean, you won't find a lot of studies which have taken into account all these three different categories of measures, like socioeconomic, climate change, and let's say regional stability or conflicts, and how they relate with child malnutrition. So this is what already has been done, and what are the potential research gaps? So let's say more than 90% of these studies, they are of cross-sectional nature, and they are for a single country analysis. So you would find these studies using logistic regression or simple OLS or other regression methods because, well, maybe they assume that the relationships are linear, but in fact, when we talk about regional studies, and I will show that in my methodology, there are a lot, there could be heterogeneous regions and heterogeneous impacts, which I think have been ignored by these cross-section studies. There could be a possibility of non-linear relationships, which have been ignored by these studies. And then when it comes to the empirical literature and theoretical discussion on how conflicts along with extreme climatic conditions plus socioeconomic deprivation affects child health outcomes at the regional level. So this is what I'm trying to contribute to this research as how these different factors affect child health outcomes at the regional level, and I'm trying to counter or will try to include or tackle heterogeneity. I will try to identify heterogeneous impacts as well, and I will try also to identify if there exists non-linear relationships. But that's like a further or future work in my other chapters. So what's the research statement? I already mentioned. So how socioeconomic deprivation, climate vulnerability, and conflict intensity influences child malnutrition. So basically childhood stunting in low and middle income countries. And for this analysis, or for my analysis, my dependent variable is childhood stunting. As I already mentioned, it's children who are under 5 years of age. And for my independent variables, I have, and in a bit, I will explain how I extracted and aggregated those variables to municipalities. So a night light intensity, which is, let's say, a satellite indicator, which is used for development or yeah, approximate as developmental measure. Then we have precipitation. Its rainfall, it's in millimeters. We have maximum temperature. So these are the number of days, like hot, humid days, where temperature exceeded 32 degrees Celsius. We have minimum temperature, male and female education attainment in years. We have diarrhea prevalence in percentage, anemia is also in percentage, exclusive breastfeeding in percentage, availability of improved and unimproved sanitation facilities. This is also in percentage, and conflicts. And then we have wheat productivity, which is 10 per hectares. And I used or retrieved this data from multiple different sources. So you won't find, because the phenomena is quite multi-dimensional, so you need to go through different or browse different platforms and see if you can find information. So I tried my best to include as many variables as I could, depending upon the literature. And so I browsed World POP. There is this Global Health Data Exchange. We have Socioeconomic Data Application Center, then NASA, then Climatology Lab. And all these data sets I use the 5 km resolution. So keep in mind when you browse through different platforms, there is a possibility that those would be at different resolutions. So you could have, I don't know, 1 km or 10 km resolution. So it's always better to use the same resolution because there are methods available. You can resample your raster files to a common or similar resolution, and then you can use those in your analysis. So how I let's say ended up in aggregating set data sets. So I mentioned we have raster files in .tiff or .nc format, and you can easily retrieve those from Global Health Data Exchange. So this is for stenting, and these files are available for the let's say for at the global level. So you can choose your country of interest. So I have chosen Pakistan, but maybe I will include some other countries as well, maybe a couple of more, because now I have all the models and everything is in place. So I just need to put the data and everything would be done. So because and why I have chosen Pakistan. So Pakistan had the highest average stenting rate in 2019, even higher than Afghanistan. So that's why I I have chosen Pakistan when it comes to studying this issue in comparison to other countries from Southern Asia. So you can easily convert this raster image to, but first you need to crop and mask this file from the global file, and then you can convert this to, let's say, grids. I don't know if it's visible, but the grid level or grid files look like this on the right hand side in the bottom. So these are equally spaced rectangles, and you have your data available at such a level. So you can easily extract uh, your your estimate at such level. So from this, then I aggregated and I took the mean values for each municipality because as these shape files, they have longitude and latitude. So you can extract data from, let's say, grids to municipalities. It's easy. I mean, it's not a really difficult thing. And I also went through my, let's say, grid files to see if there exists a lot of variation when we compare these grids at the 5 km resolution, and it wasn't, let's say, much. I mean, because you can see here, I was thinking because the municipality size differs, so maybe when you are let's say taking the mean, maybe you would find some variations at the municipality level based on how much variation exists at the grid level. But just to keep it simple and to try out my like to conduct uh, more analysis, I just took the let's say mean values for all the variables from grids to municipalities. So now I have information for each variable at the municipality level, and here I have included all the municipalities. So we are dealing here 577 municipalities. So why I had to turn to municipalities? Well, I wanted to do the analysis at the grid level, but then I found out that spatial models, because they use spatial weights matrix in their estimations, and if you are dealing with more than, let's say, I think if I'm not wrong, maybe 1,500 regions or maybe even 1,000, it's not possible. These models, they don't work. So you need to somehow choose either reduce the grids or choose maybe around under like 1,000 to 1,200 or maybe 1,500 locations. So then I thought, okay, let's do and convert this to municipality level. So that's why now I am conducting this analysis at the municipality level, and still it offers like say convincing insights when I will explain results. So when it comes to methodology, I am explaining all those steps which I went through when I was doing those estimations. So after aggregating my data at the municipality level, okay, just to mention it, so this data spans from 2000 to 2019. So we have 577 locations plus 19 years. So it's quite enough to conduct spatial analysis or panel analysis. So I started with uh, as this simple ordinary least square regression, and then I checked for multicollinearity, but thankfully there was no multicollinearity among the variables. I then tried spatial panels before turning to spatial panel estimation. And to decide about fixed effects or random effects, we need to run Hausman tests. So it turned out that fixed effects were more suitable than random effects. And to conduct spatial panel models, we need first to provide justification if we can use spatial panels, because if there is no, let's say, spatial dependency either in errors or in units or in your studied phenomena, then we cannot, there is no justification to use spatial panels. But there are different tests that you can use. I have just mentioned one of the tests which identifies spatial dependence in errors and in your variable of interest, so you can easily use and see if you are dealing with any regional level data. So we need to start with the this spatial dependency test. If it turns out that we have some significant results, then we turn to spatial panels, and choosing between spatial panels either to use fixed effects or random effects, we need to also run Hausman tests. And in my case, it turned out that fixed effects would be more suitable. So I started with this. I estimated spatial panels maximum likelihood estimation, but those results were not convincing. And then I thought, okay, maybe there is something that exists. So recently there have been few developments. So there are these dynamic spatial temporal models that takes into account not only spatial, but also temporal let's say differences, but those were not convincing as well. And then I searched more and I found, okay, there's these methods which are called spatial panels, generalized movements. So somehow those methods work, or these methods work. And when we talk about spatial panels, we can only estimate either spatial error model, spatial Durbin error model, or spatial autoregressive. So we have only these three methods to choose from. And there have been few other advancements which I'm going to try out maybe later. So we have spatial semi-parametric spline methods. So researchers, they have claimed that those methods, according to them, not only tackle like the spatial heterogeneity, but also non-linear relationships. So which is quite a huge claim as per them. So I don't know, like I will try out and we will see how those methods work out. So here I'm going to present only spatial results, so fixed effects, random effects, and pooling. And then I'm going to present spatial panel results, but from GM estimations or GM methods. But before that, let's try to see some spatial distribution of childhood stunting. And this is for the year 2015. Well, as you can see, identify like easily few clusters. So the value ranges from 30 to 70. And that's quite a lot of variation. I mean, we have some regions in, let's say, province Punjab, where the stunting rate is around 30%. Still, it's not like really low. And then we have some regions in the northern and eastern side where we have around 70 to 80%, which is quite a lot. I mean, and if we compare that with 2019, well, there isn't much improvement, and we still have a lot of, let's say, regions or heterogeneity, which is evident from this map. So the range from 30 to 60 or 65, so these numbers, it shows the scale of the problem or the seriousness of the issue at the municipality level. And next, we can also categorize or classify those regions via more on statistic, which identifies or group or cluster regions which share, let's say, similar stenting rates. So here we have on the left and on the right both sides. So let's say in this maybe light blue color, high region. So all these municipalities, they have high stenting rates and they are surrounded by those municipalities which also exhibit similar phenomena. And then on the green, we have all those municipalities grouped together have lower levels of stunting and they are surrounded by or neighbored by those municipalities which also have lower childhood stunting rates. And in between, we have some municipalities, let's say here on the eastern side in Balochistan, they are called spatial outliers. So a municipality which has, let's say, a low stunting rate, but is surrounded by a municipality which has a high stunting rate, and vice versa. So this is also quite interesting. So I also wanted to look at the more on statistic, which tries to capture spatial dependency, or in other words, how similar are the regions or municipalities in terms of stunting, either low or either high. And I skipped few years just on purpose, just to like fit this table. So from the start, from 2000, even in 2000, the statistics value was quite high. So 0.87 is quite a good value. I mean, when we talk about spatial dependence. And through the years, it has increased. So we can say that there are now regions where we have sort of a similar phenomena, either low or high. But it's not much, but they have crossed like 90%, and now it is around 93%. So let's turn to results. Well, um, we have some convincing, let's say, results. So these are spatial panels. So there is no, these models don't take into account any spatial effects. So these are simple, random, and fixed effects, and then pooling. So you can see here in these red bold text, which shows the results which are kind of unexpected. So as according to these results, it shows that okay, literacy rate is it worsens childhood stunting, which is not what we expect. I mean, or which is not what I expected. Then we have unimproved sanitation and hygiene facilities, which also is kind of unexpected. And night light intensity, well, it's a bit also, I'm a bit cautious, but let's say like it is proxied as development. So it also says that, well, the more development there is, well, it also increases stunting. But on the other hand, random effects and pooling, well, they work pretty well. So it means there is something definitely wrong with the estimation, or the model is incapable of dealing with heterogeneity, because these are aspatial panels. And I told you that I tried also spatial panel methods. And for spatial panels, when I estimated the spatial or implemented some spatial dependency tests, there was a significant spatial dependency in errors. So I chose to estimate the spatial error model, which takes into account and tries to this spatial dependency in errors. And I also estimated spatial autoregressive and spatial Durbin error model, but there was also another difference. So this is the only model which, let's say, yielded the most convincing results, because for spatial Durbin error model and spatial autoregressive, there were few variables which were insignificant and had some opposing or not convincing results. But this method, well, it gives us quite convincing and expected results. But there is also one thing that I would like to mention. So these spatial panels who uses generalized movements method, Authors have claimed that these methods not only take into account spatial dependency in errors, like if you have spatial dependency in errors, then we should use these methods, but they are also trying to tackle the problems of endogeneity, so which is also another issue. But as with these results, well, so conflicts, which is also substantial and highly significant, and I already explained potential pathways through which conflicts can affect child health outcomes, either affecting child health seeking behavior, or either affecting or disrupting food security, or either affecting, let's say, provision of health services. I also talk about here maybe briefly about standardized precipitation index, which is index composed of different climate change measures. So it says the more wet the conditions are, it reduces childhood stunting. So it means if we have lesser temperature, if we have maybe more rains, but then if we consider precipitation, it increases stunting. So we can say, or we can also, someone can think, if we are talking about here 577 municipalities, how come this precipitation has the same effect? Or you can choose any other measure from climate change. They have the same effect in all those municipalities. The effect is stationary, which is kind of difficult to, let's say, justify or explain. But well, for this, for this, the results are quite convincing. Adjusted R squared is well, quite good. And there are like some limitations for these methods because they have been recently, let's say, developed, and I don't know why they haven't provided how to extract fixed effects or some other, let's say, model diagnostic measures. I tried and I looked into a model, let's say, a summary call object, and I didn't find anything. And not only that, when it comes to spatial autoregressive model, they didn't provided uh, the impacts which we calculate, like direct and indirect impacts. So maybe they are still implementing, or I don't know even if it's possible. Maybe we'll see in future. So discussion, I already, I think, mentioned. So these are the potential direct or indirect pathways through which these different types of measures, they affect childhood stunting or child health. I mean, we can include more, but I just tried myself to be brief and easy to understand. So I'm not going to repeat myself again. I think I will quickly go through some conclusions and limitations. So one of the first challenge that I faced, well, it's I already said it's a multidimensional phenomena. So I'm trying my best to extract and looking for other variables which I could consider in this analysis. But the problem is I am using raster images. So if there is nothing available when it comes to, let's say, satellite data, then I cannot extract and use it for my study, because apart from these raster images or satellite data, there is no other data that is available that could be used at the municipality level. Um, I don't know about other countries, but especially for Pakistan or for some other countries, we don't have any such data available, because these health measures or health outcomes, they take years, because they conduct surveys and it takes years to compile and to provide such data. I wanted to do the analysis at the grid level, but then because of the estimation challenges, I had to consider or do the estimations at the municipality level. I already mentioned that I started with spatial panels maximum likelihood. It didn't work. Then I switched to dynamic spatial panels, which considers both temporal and spatial effects. It didn't work. Then I switched to spatial GM methods, which worked. They take into account and they are suited for, let's say, data sets which exhibit spatially correlated errors, and they also try to address heterogeneity. So I'm now thinking of just to robust make my analysis more robust. I'm thinking of including, or have already thought of including some maybe instruments, but I need to find something which is available at the raster level, because otherwise it's not possible. And I think I can find something related to climate change. So I would include maybe one or two instrument variables and see how it works. I also mentioned that I'm going to try out some other, or the most recent spatial semi-parametric spline models to see if they generate some more robust findings in comparison to GM methods. I wanted to include lags and seasonal variables, but because there is no single study that I can refer to provide to get some, I don't know, guidance and insights how other researchers or authors have tried to model this phenomenon. So because I can include lags or seasonal measures, but then I need to provide justification, like how those impact childhood stunting. And is it, as already mentioned, it's a really multi-dimensional and complex issue. So when you include lags and seasonality, then it becomes way more complex. So, and I don't know even if these models, they can handle such complexities. I mean, I just tried 577 locations and they didn't go. The possible solution, okay, we have GWR, but I already have something convincing from spatial GM methods. But remember that these methods, they consider this the impact of covariates as uniform across all locations, and which is not true. I mean, I already showed like there exists a huge heterogeneity, not only when it comes to child malnutrition, but also when it comes to precipitation or other climate uh, measures or socioeconomic measures. So we need to take into account those regional or municipality level heterogeneities. And the possible solution is to go for geographical weighted regression or some other, like say multi-scale geographical weighted regression or random forest geographical weighted regression methods to see how to generate or get more insights to, and also to tackle this heterogeneity issue. So, but that would be my second chapter, which I already planned. So I'm still finishing this one, and I'm going to include, because here I just included the results from spatial error model and through GM estimation, but I'm going to include spatial autoregressive and spatial Durbin error model results as well in the appendix section. And yeah, I think that's all from my side. So if you have any questions or suggestions, feel free to discuss. I hope I haven't taken much time.
Yes, you take it exactly perfectly as you were supposed to do, and thank you.
Well, I try to be summarized, I mean, because there is so much that we can talk about.
Of course, and the topic is
Maybe it's
extremely
difficult.
important and interesting. So
Well,
thank you, Muhammad, for this.